start over. We're just now starting, everyone. Hello. We have Dean Pleban here from DagsHub. He lives in Israel. DagsHub's a startup, and they're doing some amazing GitHub-like things, but with a stronger focus on data science and machine learning. So take it away, Dean.
Yeah, thank you everyone for joining and for taking time. So I'm going to be talking about DagsHub today. I'll go over a few slides just so you get a high-level overview of what we're building, and then we'll dive into sort of a few live examples and use cases. And I like to do this informally in general whenever I do this. So if you have any questions, please feel free to ask. I will probably not see them if they're on the chat, so feel free to just like unmute and ask, and I'll do my best to answer in real time. So yeah, so I am one of the founders of DagsHub, and DagsHub is sort of a place we built for you to create your next data science or machine learning project. Another way, as Tom said a bit earlier, to describe it is like kind of like GitHub for machine learning. So our idea is like GitHub is great when you're working with code, but it doesn't cover everything that data scientists need, namely managing data, models, experiments, pipelines, notebooks, things like that. And so the idea with DagsHub is sort of to take what's great about GitHub, but expand that to the sort of all of the different components that data scientists care about. So the company was founded by Guy and myself. We've been friends since kindergarten. We both have technical backgrounds. And sort of the reason we started DagsHub is we both had the experience of working on machine learning projects. And we realized that if you're working just with code, your life is pretty awesome. But the moment you add data into the mix, things start to sort of fall apart and don't really make as much sense. We're good engineers. So we always assumed that smarter people than us had these problems and solved them. But we went out to the internet and we realized that that was not really the case. And it was very clear that there is sort of a lack of standard workflow, a lack of standard tooling, and there was no place that data scientists went to call home, if you will. And then there's this other thing that we now call Emelops Fatigue, which just means that there are so many tools to choose from and then integrate with, and then many times manually sync. And that leads to a lot of pain for data scientists and teams. And so the idea with DagsHub was, let's try to sort this out and make some sense of this entire thing. So how does this work? The idea is, let's not reinvent the wheel, right? Let's take these great tools and let's integrate with them so that we sort of scan the information coming from these different tools. We build out a dashboard that is sort of managing the code, the models, the data sets, experiments, notebooks, and pipelines all in one place. And that is sort of reflected in a way that every person that you're working with can sort of make sense of what's going on in the project and review the work being done. And then you can connect that to automations that run across the sort of entire set of components. So to give like a few concrete examples, you can push data to DagsHub and then start labeling it with the click of a button, and then save those labels back to where you want to sort of manage them, which is your project, and then pull them into Google Colab or SageMaker or wherever you train your models, and then train them and push the trained model back and then deploy it to production. So all of these sort of activities happen where DagsHub is sort of the central place where you manage these components, and then you pull some of them out for certain automations or certain processing steps and things like that. So this is like a very high level overview. I think I'll say another two things, which is, again, we don't believe in reinventing the wheel. So wherever we can, we sort of take the existing best of breed solution for a sort of given task that you might want to do, like experiment tracking or labeling or data management. And then what we're trying to do, because we're sort of saving time by not reinventing the wheel, we're spending that time on building a workflow that actually makes sense for working with all of these tools. So I'll stop here and see if you have any questions, and then we'll dive into the platform itself. Awesome. So I'll stop sharing this screen. And I'll move to the actual platform.
Sorry, Dean, I was on mute. Let me ask a quick question.
Sure.
Even though I'm a DagsHub super user, I do have a question. No, seriously. So if you go back to the slides, that one that had the orchestration, was that just an icon for orchestration, or is there a tool for orchestration that's out there?
So you mean, sorry, there. You mean this part?
Yeah, the little guy that was orchestration, bottom left, but one up from the bottom, orchestration. Yeah. Is there a tool for that out there, or are you doing the orchestration with DagsHub?
Yeah, so we're integrated with Jenkins, and so our approach is like so orchestration is like obviously a big term, and it means different things in different contexts. But the way we think about it is most of our users want to use what they want to use. And I guess that sort of makes sense. And so our goal is to make it as easy as possible to do that. But we currently are not providing our own sort of orchestration engine because there are these great solutions that exist, and sort of that wasn't our focus so far. But I'd be curious actually it's too bad Zoom doesn't have convenient polls. I'd be curious to hear like what everyone here is using to run experiments and deploy models and things like that. So this is something that we're thinking about a lot. Currently, we're integrated with Jenkins, but we also have like real projects where people are using DagsHub with, for example, SageMaker to train models. We've seen people use it as part of like Airflow. Even though there's no official integration, you can pull the information. And the nice thing is about the way we implemented things is because everything is based on Git and DVC in standard formats, it's basically very easy to connect it to whatever tool you're using, because you just Git pull and DVC pull, and you have everything wherever you want to run it. So that's sort of our current approach to that.
I love it. I really love it that it's integrated with VS Code, but especially with Colab. That's king right there. And then I wonder why you didn't, well, is one of these symbols for Jenkins next to orchestration?
Yeah, the butler is Jenkins.
Okay, that I'd never seen the icon for Jenkins, but guys, I've used Jenkins. It's a lifesaver if you're going to try to move from, in DevOps, and MLOps is very similar, but DevOps and MLOps are not exactly the same. And so as you're moving that direction, there's a thing in DevOps, guys, called no-ops. That's where everything's so automated, and it's got so many checks, it's hands off. You don't have to worry about it anymore. And then you think, no way. Well, yeah, and there's something above that, AI DevOps, AI-based DevOps, where it's starting to look, AI is starting to look for gotchas. Dean, correct me on anything I just said, but I couldn't help, because I did do a book review on a book for Pact on DevOps. And it was SecOps, and it included everything I just mentioned. So please go on, but I'm just excited Jenkins is part of the orchestration.
Yeah, I think that it's like you're basically referring to like the next meta level, where you can actually train a model to do a better job in deploying either software or other models. And we see that, I mean, to be fair, this is happening only in the more, let's say, sophisticated and advanced organizations right now, because there are a lot of challenges, but there are a lot of companies that are actually building that as sort of an off-the-shelf product that you will be able to integrate into your DevOps pipelines. So yeah, it's a very interesting area. So I see that also Amir has a question.
Yeah, exactly. Amir, please go.
Yeah, sure. Hi, Dean. So as I see here, there are a lot of different aspects and different, I think, areas where DagsHub is trying to integrate a lot of stuff. I wanted to ask, what was the, like, I think I missed this. What was the gap that you identified that DagsHub could fill? Like earlier, how did DagsHub came into ideation? And also, you mentioned that people can come here, people can pull the data, label it, and then train it on, let's say, Collab. So, do you think, or do you have any plans to make DagsHub a one-stop solution for everything? Let's say training, implementing everything.
Yeah. Okay. So the first question is like, what was the gap that we identified? I think that the gap was divided into two. First is that it seemed like there were a lot of tools that had like point solutions. And you could say, like, you have a tool for experiment tracking, you have a tool for data version control, but there was no place that sort of was trying to make sense of all of those tools. And so what we saw people were usually doing is they either had to spend a lot of time choosing which tools to use, and then setting up like hosted versions, and then basically like inventing ways to work on them in a sort of more organized way. And that seemed very strange to us, because like basically what you want to do is you want to create a standard. And the way that standard should work, at least in our minds, is it should be like not data type dependent. So for example, if you think about code, you don't have a different code review process if you're working on Java or C. Like the pull request is the same pull request, the GitHub is the same GitHub. And so in the same sense, like we imagine that data review should be the same whether you're using images, MRI, or tables, right? And so all of that didn't really exist. And still today, like last week, I spoke with a very serious company. I won't name names because it's a company with multiple tens of thousands of employees. And their review process is basically non-existent. Like they reinvent it every time that there's something new to review. And so that to us seemed like it shouldn't be the case. Like it shouldn't work like this. And so that's sort of what set us off on this journey. And then the other thing is like again, like the community aspect. I think it was the first one. The first blog post I wrote on the DagsHub blog, if you go like back to the first page, it's about like open source data science and open source machine learning. And if you think about everything that exists today on GitHub, like you have machine learning projects, right? But you can't really contribute to those projects as a data scientist. You can only contribute to, like if you find a code bug, right? Then you can open it, like fix that bug and open a pull request. But what if you found like that the data is actually not representative? So I'll give like a stupid example, but you have a food identifier, like a food classifier, and now you realize that they don't have my favorite dish, which is hummus. And so you want to contribute more data, which is labeled for that dish, right? And there's no real way for you to do that. You have to sort of contact the owners and tell them that you'll send it over via email or send them a Google Drive link, and then they have to incorporate that and train the model again and all of that. That seems strange to us. So the idea was like, you need to be able, like the golden standard for collaboration is two people on the opposite sides of the globe that have never met each other should be able to work together on the same project. And if we solve this, then we're going to do a lot of amazing things. And so I think those two things were like the sort of inspiration that we took that pushed us to build this. And then the second question you had was about like a one-stop shop. So I think like, we want to build a one-stop shop, but in a unique way. So I don't think we want to have DagsHub as the central place for collaboration, but we really believe that there's a lot of strength in taking sort of the best tools that other people have built and making it easier for everyone to use them. And so I don't see ourselves like, I don't know, you have Google Colab, right? Like everyone loves Colab. I don't see us re-implementing Colab. Like we might offer a very basic, self-hosted Python notebook integration or something like that. But the idea that you can just use Colab with DagsHub, I think is more powerful. And so we'll have sort of the way we imagine it is in the future, when you click create on DagsHub, you'll have a list of all the possible integrations and you'll be able to say like, I want to use this, and this. And then everything will be set up and you can start working with the tools that you want. That's the one-stop shop that we imagine, which is kind of different than like, maybe the Databricks example or something like that, where everything is built by the same company. So hopefully that answers the question. And Sai, I see you want to ask something as well.
Yeah, I just want to ask, during this integration of all these things, what are the common things that you found out? Like, these are everything are different. Like data is different. There's some different person assigned for data engineering. There's some different person assigned. But during integrating all these things and making a dashboard, is there any common things that you identified which you wish to share? Like, I am just curious. Like, what are those?
So when you say commonalities, in what sense do you mean? Like there are a lot of interesting things that we discovered starting to integrate this. But yeah, I think the question, are you asking this from the perspective of like let's say the software engineer integrating, or like the workflow from a data scientist perspective?
Can you tell about both? Like,
fair enough. Yeah, that's a bad question because the answer is always both, right? So from an engineering perspective, I think that one of the things that we realized early on, but we keep realizing how important it is. And I'm also a host of the Emelops podcast. And so I had the CTO of Hugging Face on for one episode, and we discussed this as well. And that is API design, right? Like thinking, or not, maybe API design is too specific, like interface design, right? Thinking about how different components interact with each other in a way that is sort of modular to begin with is very hard. Like you need to hold very complex structures in your head in order to do this right. And it's very hard to do this right on the first time. But one of the things that you learn integrating multiple tools that do the same thing, or not the same, but similar things, is sort of what are the layers of abstraction that you need to think about in order for this to not be increasingly hard to add another tool, right? Because if every time you integrate a new tool, you only think about that tool, then you're going to do like one tool and that's going to be easy. And then on the second tool, you're going to have to think about two tools now. And then afterwards, three tools and four tools. It's going to be exponentially like difficult because of sort of the amount of things that you need to hold in your head. But if you build a good interface to begin with, then modifying it should be modular. Like you can clear your head of all the complexity of the system that you're building and just focus on that. And to give a concrete example of this, we do a lot of, as I said, like part of the things that we believe is that it shouldn't matter what data type you're using. Like it doesn't matter if you're using audio, or you're working with audio data or text or MRIs, right? And so we've had to build a lot of different visualizations for these data types. And when we started out, like doing the first one was okay, and the second one was a bit harder. And then we realized that we have to sort of redesign the system so it's really easy to add new file types. And so now, the last time I added a file, I was actually planning on doing one this weekend, but I ended up working on something else. But the last time we added a new data type, which was audio data, it took me literally one day to finish adding it out and having it in production. And so the ability to build out a system which is modular enough to be fast in doing that, that is something that is sort of counterintuitive, I think, and very hard to accomplish. But if you do it right, then it's going to save you a ton of time. So that's, I think, like one learning, one learning from the engineering aspect. I think from the data scientist aspect, the main thing that we've sort of that we've learned along the way is like, what are recurring themes in use cases? Like, how do people work when they manage experiments? How do people think about data management with experiment tracking and things like that? I feel like that is more case by case specific. There are a lot of different things there that are really dependent on how you're working. But for example, one recurring thing that we've seen is that because the complexity of machine learning projects is going up, the idea that you have sort of I guess it's also somewhat related to the interface. It's the same thing, but from the data scientist perspective. And I'll show an example of this in a few moments. But the idea that you can split a machine learning project or a machine learning pipeline into multiple projects so that multiple people or multiple teams even can work on the same sort of product at the same time without stepping on each other's toes. That's something that was not intuitive to us when we got started. And now we have sort of a deeper understanding of how that works and how that should work also from a technological perspective. So I'll show an example, which is going to be much simpler, but just to keep in mind, like companies like Tesla are working this way. So they're like splitting models so that if you have like one team working on, for example, lane detection and another team working on pedestrian detection, they don't have to wait for the other team to be ready in order to deploy stuff to production. Like you can deploy a new lane detection model while someone is working on the pedestrian detection model and sort of get the best result as soon as it's ready, if that makes sense. So this is a bit high level. I'll try to show examples of what I mean.
Before he goes to that, oh yeah, go ahead, Sai.
Oh, just it was fine. That's it.
Good.
Yeah. So Tom, you wanted to ask something, or I'll go?
No, I wanted to make sure before you went on, if anyone had any questions. I'm loving this, by the way.
Awesome. Yeah, I'm having fun. So I'll wait. This is, sorry. Okay. Yeah, I'll move to show DagsHub. So usually I joke that we don't have demos because everything is live. So if you sign up to DagsHub, you're going to see exactly the same thing that I'm showing you, aside from the fact that my dashboard is a bit fuller than yours is going to be probably. But the idea is like everything you're seeing is the live version. Let me remove the bookmarks just so we have less.
Oh, I need to ask the obvious question.
Yeah.
Dean,
there.
Are you using DagsHub to develop DagsHub?
So we had a dilemma if we want to do that. We felt like we're using GitHub, and so to us, like DagsHub, we're building it to be dedicated to machine learning projects, and so we're all working with DagsHub on a regular basis. But even like when we're speaking to companies that have like both developer and data science teams, we recommend developers continue working on GitHub or GitLab or whatever they're using. And part of the reason we built the integrations to begin with is because you want the developers to work where they're comfortable. You want the data scientists to work where they're comfortable, which is DagsHub. But you want that connection so that they can each sort of see what someone else is working on in sort of their home turf, and not worry about that sort of splitting the workforce, if that makes sense. So yeah, so this is DagsHub. Now, if you go to the Explore page, you're going to see sort of projects that were created by our community. So these are all like real projects. Most of them I have no idea what they are about. So you can just like look around and see if you find interesting things. I'll go to one project that I am sort of working on in my spare time. I'll show multiple projects in this, but this is the project that I'm most familiar with. And I didn't mention this, but my comfort zone in machine learning is computer vision. So that might be a recurring theme. I apologize in advance if you're like NLP people or something like that, but DagsHub works for all of these different data types, so don't worry about it. And so this project is called Safta. Like a funny anecdote is, Safta in Hebrew is grandma. And the reason we chose this name and we chose this project is we wanted something like a machine learning task that even if you explained it to your grandma, she could understand what you're doing. So not like something that's super esoteric. And so basically what we're doing here is monocular depth estimation. So this is Sunny, my dog. She's sleeping on the couch over there. And what we're trying to do is take a neural network to estimate the depth of the different components in the image. So the reason this looks really bad is it's the first model. I promise you the latest model is better. And so this is interesting because this is like, these models are actually used in self-driving cars. They're actually used like to create 3D photos. So they have like real world uses, but everyone can understand what's happening here. Like it's very intuitive. And so when I started this project, I had no previous experience in monocular depth estimation. So the first thing I did is I went to Google Colab and I created a notebook. And so the first instance of the integration with DagsHub is I would just like push my notebook to DagsHub, and you can see the notebook here. And of course, this is already the latest model. So as you can see, like this is sort of the output. So this is the input to the model. This is the expected output, so the label, and this is what my model actually predicted. So at this point, it's pretty close. But obviously, it wasn't always this good. So when I started out, and this is sort of one thing that is already unique to DagsHub, you can diff notebooks in a human readable way. So you can see sort of how the code changed and everything, but here you can also see outputs. And so you can see my bad first iteration model, and you can see on the left the good last iteration model. And so the idea that you can sort of gauge the development of your process, your processor, your project via these notebook diffs is really valuable to a lot of people. One of the interesting ways that people use this is they actually, like, imagine you have you have even a data set, right? And that data is updated all the time, but it's not sort of necessarily intuitive what changes are happening in that data. So one thing that we've seen is people build a notebook, which is effectively sort of a dashboard. And every time the data or the model is updated, they run that dashboard, and then they compare the results by notebook comparison. And so that's a great way to compare like metadata for your data set, which is custom, because obviously no one will ever know your data set as good as you do. And this is sort of a very customizable way to make sense of what's going on in your project. So this is like one thing. I'll stop here. Any questions about this so far? It's just a tiny feature, but yeah.
Well, this is amazing to me because using various types of version control and then diffing my files, I never imagined with our talks, Dean, I hadn't gotten to the point where I realized it will diff the outputs. And of course, the outputs are embedded in the notebooks. So that's a huge gain right there. The integration of well, I wonder too, do you diff the data inputs also? Or is there ever a strong need for that in your opinion? So
we diff basically everything. I'll show an example of a more complex diff. So I guess, well, maybe I need to explain a bit more about how we manage data, and then I'll show it. But basically, the answer is yes. We diff whatever changes the project, whether it's the input data, artifacts, models, notebooks, anything you have. Let me explain how that works, and then I'll show you an example. So this is the project, and what I usually say here is, if you've ever looked at a GitHub project, this should look familiar, right? Like, the idea is we're not reinventing the UI. You don't need to relearn something. You're convenient or you're comfortable sort of at home, right? But there are a few differences, and each one of these differences is something that data scientists would care about. So one of the things that people usually notice straight away is, like, we have tabs. So one of the things that we're doing is we're scanning all the files of your project, and we're identifying what might be a data set. So if I click data, you can see, and these are like a bunch of different heuristics. You can see sort of the files that are probably data sets or data files. Same for models and notebooks, DVC, which I'll get to in a moment, and then obviously your Git track files. Now, another thing is sort of this button, right? So in GitHub, you have a green button that says code, but on DagsHub, it says remote, because we're not just managing your code. So when I click this, we have like three things here. The first is a Git remote, which is same as the Git remote you have in GitHub. And you can connect, as I mentioned, you can connect your DagsHub project to GitHub. And if you do that, you would see a URL here, which says like github.com and whatever it is. And so the idea is you can also work by pushing code to GitHub and having it synchronized to DagsHub. But if you want to have everything here, you can do that as well. The second thing that you get is a DVC remote. So I'll take a step back. I'll explain what DVC is for those that aren't familiar. So DVC is short for data version control. It is an open source project that extends Git in order to manage large files like data, models, artifacts, things like that. It also has some pipeline management skills or features, and then some very basic experiment management features that are based on Git. But I'm not going to talk too much about the experiment features. I think what DVC does best is manage data. And so the idea is by the way, if any of you are familiar with Git LFS, it's kind of like Git LFS if it was implemented a bit better. I know that is a hot take, but it's more fun to have strong opinions. So the idea is like it's similar to the working method of Git LFS, but it works directly with your cloud storage. So if you want to push your data directly to AWS S3 or Google Cloud Storage or Google Drive or DagsHub Storage, then you don't need to install a special server or something like that. You just push it, and it works with the standard libraries. So yeah, Tom, go ahead.
So forgive me, this is a little bit of a picky question.
Sure.
You don't have SSH capabilities yet, is that accurate?
Yeah, so we actually, SSH is like a painful point. So when we started, we had SSH. And then we canceled it because it's more of a security risk, and it needs to be my partner is like his background is in cybersecurity, so he's very sort of self-aware about the sort of risks there. And so he decided that we want to do this right and not do this like half-assed and then have issues. And so we canceled it for now. This is something that we'll probably add in the future or re-add in the future. But yeah, currently it's based on HTTPS.
I wasn't aware that. I always kind of assumed SSH was safer than HTTPS, but I probably put too many T's there. Is that accurate? Is that what your partner is saying, that it's SSH has some security holes?
Yeah, so SSH basically, this is like very getting into the details, but SSH basically gives the users access to a server to run commands on that server, as opposed to HTTP, which is just like an API. So the thing about that is, if you do not separate the SSH server from the main server, and you have a bug, you might by accident give the user like root access to everything, right? And you do not want to do that. And so that's sort of the risk there. And that's why we decided to wait with that for a later stage. Awesome. So let's get back to DVC. So the idea is, again, what we did here with DagsHub is basically every project comes with a DVC remote. And what we did is we implemented the easiest to set up DVC remote. So if you copy these 4 commands to your local system, you'll be able to start pushing data and models to your project, right? And if you're not completely sure on how that works, like I'm not going to do like a live coding too much, but you can go to our docs. There's a getting started section that will cover how to do this. And it's very straightforward. So you push your code, you push your data. What do you get on DagsHub? So
give me, what does DVC stand for?
So DVC is short for data version control.
Okay, that's what I thought. I just wanted to make sure.
Yeah. So basically, if all of these look like Git tracked files, if I go into my source folder, you're going to start seeing files that have like the DVC badge. And so what we're actually doing here is, like, if you see this project on GitHub, these folders would not exist because they're not managed by Git. And so part of the magic that we do at DagsHub is we scan all of this information, as I showed you earlier in the diagram, and then we piece together the data so that you see it as if it was on your local system, right? Like you have a folder that says data, and inside it you have your data. So you'd expect to see the same thing when you're on the central server. And so when I go into my processed folder, I'm actually now looking at folders and files that aren't managed by Git. So let's just open this one. And so you can see this cafe, which sort of reminds me of the cafe in the Friends show. I don't know why. And you can also see sort of the depth map, which is the label. And all of this is data, not managed by DVC, not managed by Git rather. And you're seeing it as if it was just another Git file. And now I'm going to go back to, I think it was Tom's question in the beginning. Treating data as if it was code is not just showing you the data, right? It's also diffing it. And so one of the things that we do, and this is like something that really happened to me. So I had a bug in this project, and I was saving the values of the data, of the predictions opposite of what they should be. And so that ruined performance, of course. And what you can see here is you can see the diff of that data. And this is a bad image. Let's look at this one. I think it's better. So yeah, so you can see the diff of the images, and both of these files are not managed by Git, but we're still giving you the comparison as if it was managed by Git, including like going back in history to a specific version and things like that. And so instead of like taking screenshots and sharing them on Slack, you actually have sort of a URL that you can copy and send to people you're working with, and sort of you can have that discussion on what's going on. So this is just a few examples. Another thing that you might have noticed is we're doing a like directory diff. And this is one of the things that we did not think about getting started with DagsHub. And one of our users asked for this, and then we built it, and we realized like now I feel kind of bummed out every time I do a diff on GitHub because I don't have this. And so the reason behind implementing this is if you only changed 4 files, then seeing them as a list like this makes sense, right? But if you have 3,000 files that have changed because you change your data, looking at a list of 3,000 files is not going to tell you a lot. And what you actually would want is you want to preserve the structure and see how that structure has changed. And so with DagsHub, we can show you like which directories have changed and which files in that directories have changed and things like that. And that provides sort of a lot of value in making sense of changes in your project. So I already showed you notebook diffs. I showed you image diffs. Obviously, you have text diffs. You also have tabular diffs on DagsHub. So we can compare tables and show you how they've changed. And we do this, again, with any of the file types that we support. So also audio and MRI data and things like that. Okay, so we talked about data, and now we have like our data managed, and that's awesome. The next step would be to build out a pipeline, right? And so the next thing that we do on DagsHub is we sort of, as I mentioned, DBC provides data pipeline management capabilities. So with DagsHub, we scan that pipeline and we build that into an interactive visualization. So what that means is if we look at the raw information, this is how the pipeline looks, right? So this is relatively human readable. You have like the stages, each stage has a name, the command, dependencies, outputs, and things like that. That's great. But you can imagine if you had 50 stages, it wouldn't be so easy to make sense of what's going on. And also like even here, it's kind of hard to understand what's related to what. And so we're scanning this information and we're building out this really nice pipeline. And so why is it nice? Well, first you understand what's going on in your project. So I can explain to you, even if this is the first time you're looking at this project, that what we're doing is we're bringing data from the internet. That's the golden nodes. We're starting to track the raw data. We're doing a process data step. So we get process data, then we have a train and test data set. We take the train data set and then we train a model. We get the model, and then we take the test data set and we evaluate it and we get metrics and examples. So now what can you do with this pipeline? The first is you can use this to actually see what the performance is. So you can actually look at the model performance here and sort of see what's going on without going any further. But you can also use this as a way to navigate your project. So if you want to look at the examples that your model predicted, instead of figuring out where they are saved here, you can actually just go to the examples and it will open the right place within your project. Which I think is really nice and convenient, and we see a lot of people using this. And this is also version specific. So if you move back to history, so for example, I added the examples at a later stage. If I move back in history to, I think this is before that, and I'm looking at the pipeline now, no, this still has examples. Let's go earlier. So if I go to an earlier stage of my project, here, now my evaluation step only has the metrics. It doesn't have the evaluation, the predictions that I saved aside. So you can also make sense of how the structure of your project has changed over time via this visualization. And that's sort of the pipeline in a nutshell. I'll stop here for a moment and see if anyone has questions before I move on to MLflow and experiments and then a bit more advanced use cases.
I have a burning question.
Sure.
All right. Let's say you've got a SaaS of some kind, or you've got a website for your business, but there's a lot of machine learning experiments going on regarding the performance of that website. Would you, in such a case, encourage both the full stack coders and the data scientists to do everything in DagsHub in that sort of case?
So I think it's usually still well defined what is the responsibility of the data scientist and the developer. And so I can talk about like I think the physics term in English would be like the deformed cases or degenerate cases where you need developers in order to help data scientists deploy or take like their models and put them in production. But the standard case, I think, is like the data scientists can get data from the database, work on it, build their model, and the developers can continue working and building the product without needing to sort of interface directly with the data scientists. I'm trying to think if we have like concrete examples of users that like onboarded their developer team to DagsHub. I can't, like, there are a lot of users. Obviously, we have our community has over 7,000 people right now, so I'm guessing there are a lot of projects I don't know about. But from the ones I do, I don't think that we've had like developers use DagsHub in tandem. It's usually, again, like there's a good definition of what should be the responsibility of each team. And yeah, like in specific cases, I can probably explain like the solution architecting behind that. But the idea should be that the data scientists can build a model, and then the developers will just use this is what you discussed earlier, by the way, the API for like single files. They'll just use that to access the most recent model and incorporate that into their product or platform.
Oh, that makes sense to me now. I was just curious because of for a smaller team, I wonder if it still makes sense for the full stack developers to use something like GitHub and then the data science type work residing on DagsHub. And I think I understand why you're saying that. In fact, it's probably better to have the two separate repos, is kind of what I hear you implying.
Yeah. Yeah, again, this is also related to the interface design question. It's basically the reality is a huge interface, right? That's the takeaway from this talk. So part of that is like, if you can separate work, that means you can usually move faster, right? Because if you imagine that the code for a product or an app and the model that is running within that app, if that has to be in the same repository, then you have to wait for every time for everything to be stable in order to deploy something new. And that usually causes a lot of like, there's too many dependencies in such a case. So that usually slows down development. And what you'd actually want is to be able to like push out updates to the product and push out updates to the model, irrespective of each other. But yeah, that's not always the case. And actually, I'm not sure, like in very small teams, I guess everyone does everything, and then maybe they do work on DagsHub. But I think like if there's already a separation between developers and data scientists, then it probably makes sense to have a separation between the platforms as well. Cool. So now we're getting to the next bit. So let's say I built my pipeline. Now I'm ready to start experimenting. So as you saw earlier, with every project on DagsHub, you also get an MLflow tracking remote. And so basically, it's the same idea with DVC. Like, we have an MLflow server. One of the challenges with MLflow is like setting it up locally is very easy. Setting up a central server is not that easy. And so with DagsHub, we save you that sort of effort. And so you can just copy these three environment variables and start logging experiments. And we actually support two different types of experiment tracking methodologies. And one of them is Emelflow, which is pretty straightforward. If you haven't used it, it's basically like you have a Python API, you have calls to log metrics, to log parameters and things like that. The other option is you use Git. And so in this project, I'm using that. And so what you see is I have like a parameter file, which is basically like key value pairs. And then also we have like the metrics, which is like a CSV of name, value, timestamp, step. And if you use this format, and we also provide like a logger for this, so it's very easy. Again, like, so you get a similar experience to Emelflow. It creates these files, and when you commit them to Git, we scan them and incorporate them into the experiments table. And so the experiments table, you're going to see the same thing if this was Emelflow, just that instead of Git, it would say like Emelflow here. And so what you see is like a table with columns for like metadata, columns for parameters, and columns for metrics. And of course, you can change these to see like the things that you actually care about. I don't know, validation loss. And so this is very customizable. And then, for example, you might want to compare different experiments. So you can select multiple experiments and click compare. And then you're going to see first tabular comparison. So comparing like the different metrics and parameters. You can see a parallel coordinate plot, which is interactive. So in this case, my experiment was actually just changing the amount of time I'm training the model. And you can see sort of the different metrics and how they were affected. So this is after I fixed the bug that I showed you earlier. One of the ways I identified that I had a bug is like it was all over the place. So that it meant nothing. Like obviously you'd expect that when you train the model for longer, it's going to be better. And that wasn't the case. So that's how I knew I have a problem. And obviously the final thing is like comparing metrics side by side for the different charts. So you can do that as well. And this is sort of helpful in making decisions on what's working, what's not working, what to do next. But let me just show you one small thing which is unique to DagsHub. So I looked at these experiments and I realized that the 50 epoch training session is the one that I actually want. So I go here and I can click this experiment. Now, what's different about DagsHub compared to just using Emelflow is when I'm clicking the code button, I'm now going to the project and seeing all of the project components when exactly the same way they were when I created that experiment. So I'm not just looking at the code, I'm actually looking at the exact data version, I'm looking at the exact model output, I'm looking at the exact metrics and parameters. So this is like fully reproducible from the get-go. And that was something that was really important for us when we built this. So that's sort of the logic behind that on DagsHub. Now let's get into, I'll talk about two other cool things that we have, and then we'll talk about like an advanced use case just so we're not just going over the basics. Another thing, as I mentioned, like we want to enable people that have never met each other to work together on the same project, and we want to enable people to build a knowledge base. And so part of that is building discussions. I know GitHub also has a feature called discussions, but DagsHub discussions is completely different. The idea with DagsHub is that you can comment on any file within your project. So I'm going into this image file, right? You can have a discussion and sort of preserve context. So if you're now going back to this file in this case, after 3 weeks, you still see what the discussion was. And part of this is also has been building the sort of capabilities to comment on things that data scientists care about. So for example, you can comment on bounding boxes with images. So if I think this is not the soap, but this is actually the soap, I can mark this and say like, this is the soap, and then add that as a comment. And this will also be shown here as well. You can comment on notebook cells, you can comment on code lines, and we're adding more and more capabilities for commenting as time goes by. But that's part of what we think is important. So you can imagine like a lot of times people want to discuss which model architecture they use, and then they do that in Slack. And then you go back and you open a pull request like 3 months later, like, look, you remember that discussion we had? Now this is the pull request for that discussion. And so the idea with DagsHub is if you have that discussion on the model file, when you open the pull request, you're going to see that discussion in a very intuitive way. So you don't have to go looking for it and remember why you thought like adding another dense layer is the right or wrong thing to do, right? So that's how we're thinking about discussions. And one of the surprising things is when we released this, we didn't tell anyone about it, and people started using it on their own. So I think that people really need this, and so we're excited to see like how people are using this, and I think that's one really simple but very cool feature. And then the last thing is annotations. So I mentioned this very briefly, but you can now annotate data on DagsHub, and the way that works is if any data file that you push to DagsHub, you can now annotate. And you don't need to do anything special in order to do that. You basically push the data. So in this case, we pushed a bunch of different data types so we can show how we label all of them. So we have like images here. And so you can see those images. If you go into annotations, you see Label Studio project. So Label Studio is yet another awesome open source tool for data annotation. And when you click this instance, it's going to open an almost completely standard Label Studio instance. We changed two things. The first is if you go to settings and you look at DagsHub, what we're basically doing is we're scanning all the files within your project, and we let you choose which files you want to label. So you can actually say, I want to label images, and then click save, and all of that is sort of ready to go, and you can start labeling. And then after you finish labeling, so you can go here and you can see some labels that someone did. You can submit those. You can obviously continue editing, I guess. Yeah. So you can click this and then, add another label and update that. And once you're done, you can click, after you've updated your labels, you can actually, let me move this aside, sorry. You can click the commit button. And what that does is it's going to save those annotations back to DagsHub alongside your data. So if one of the challenges that we saw that people had with annotations is like annotating data, like what I did right now, like adding this is not that hard. The challenge is like, how do I get my data to where I'm annotating it? How do I get my annotations back to where I'm training the model? And so the idea is we solve that with the sync that I showed you and with the commit button. So after you commit this back, what you get is this. Let me show you. So showing data or showing file types is not enough. We're also showing you the annotations themselves. And so what that means is you can actually see annotations within DagsHub, and you can see like which image they're related to. And so that means that you can actually now promote the review process for annotations to be like a pull request. And so if annotations change, because many times the first round of annotations is not that good, with DagsHub, you can actually see how that changes over time and time travel in annotations. So if you want to see how annotations were 3 months ago, you can go back to that, open a new Label Studio instance, and then start editing from there, which I think is really cool. And as far as I know, this is the only place you can do that. So this is like a very quick overview of a lot of the awesome features that we have on DagsHub. I want to show you what I mentioned earlier about like cross-project dependencies, which I think is a really cool and more advanced use case. But I want to stop here for a moment and see if anyone has questions. See that?
You gave me a private tour, Dean. And I got to say, this one is so much better. I'm starting to get why it's so good. So I've got a sticky question for you, though.
Sure.
Now, I'm asking this because I want you and your CTO to go big. I want you to do great with this.
Mm-hmm.
I do have a business fear for you. Can you guess what it is?
I don't know. You're going to tell me. So.
Well,
Yeah.
what's to keep the gorilla GitHub from starting to offer the same services you guys do? And can you stay on the top of the market if they decide they want to take you on?
Yeah. So I think it's a fair question. To be completely fair, we've been asked this a few times, so I have I think a decent answer already. But sort of the way we think about this is data scientists and developers have a lot of similarities, but they're not the same persona. And if you think about the audience for GitHub, there are a lot of people that are very far from data scientists, like cybersecurity developers or game developers or web developers, right? And GitHub needs to cater to all of these groups, and they probably won't sort of completely neglect one group to cater to the other. And so one of the things that we view as an advantage for us is we choose data scientists every turn of the road, right? So whenever there's a dilemma, and maybe there's something that would be better off better for you if you're a game developer, we just don't do that. We do what's better for you as a data scientist or a machine learning engineer, and that's sort of our sole focus, and that lets us, make decisions faster, build more things for for the audience that we care about, and sort of build a more well-rounded product for the subset of users, which are data scientists, or the subset of GitHub users. To give a concrete example, I don't know how many people here know about this, but when we started DagsHub, people were already asking GitHub to add notebook diffing to GitHub, and that has still not happened. And we built that in like a week, right? Because we decided that this is very important to our users. And so I think that is one concrete example where that makes sense. The other thing is, because we're managing non-code components, there's a lot of infrastructure that is sort of like part of the magic is basically we're making all of this look easy, right? Like the idea is we're treating data as if it was code. So the idea is it seems really easy to load data files, right? And show them as if they were code. But you can imagine that the level of complexity that we need to handle, so for example, millions of images, terabytes of data, things like that, that is something that is not very straightforward to build out, especially if you need to take a lot of different sort of, again, audiences and features into consideration. And so I think that that is sort of the competitive advantage, if you will. But yeah, but that's what has held us up so far. And I think that GitHub is not, it's not that they're not trying. I just think that it's going to be harder for them because of everything that I just mentioned.
I think that could be the thing that wins for you, because they have to focus so broadly. You get that narrower focus, you can develop in that area faster, of course. I hope y'all win big. That's why I asked the question.
I appreciate that. Yeah, no, it's a good question. And I think you don't want to get too complacent, right? You need to keep aware, make sense, like see what's going on around you, and also sort of predict where things are going and make sure that you build for the future and not for yesterday. But I think that that's sort of the way we see our advantage right now, and I don't see that changing in the near future, but you never know. Yeah, anyone else want to ask a question before I go on to the advanced use case? I'll open it in the meantime, but yeah, go ahead if anyone has. Okay, so we are staying within the Baby Yoda realm. And what I'm going to show you is sort of a usage pattern that we call data registry or data repository. And the idea here is exactly what I said in the beginning. If you make your projects modular, you can do more and move faster. And so the idea here is it's a very simple design pattern, if I guess you could call it, like a data science design pattern. And we have a blog about this, by the way. If you go to our blog and you search for data sets should behave like Git repositories, it's a really great blog, and I recommend it. So Simon is one of our developers. He wrote it and he built this example project. And so what's the idea? Okay, the idea is, imagine you have a company and you're working on some data set, and you have 5 different teams that are working on the same data, right? So you can do 2 things. The first is each team has a copy of the data set and they're working with that. And so if there's a change to the data set, then all 5 teams need to sort of update it individually. And if 2 teams updated it, but 3 others didn't, then you need to make sure that someone on those 3 teams knows that something has changed, or otherwise they're going to mess up their performance or deploy something bad to production. That is obviously, that sounds like a lot of repetition. So that's usually like something that should alert us to the fact that maybe we're not being efficient. And so what we propose here is you have one project that is a data registry, and the only purpose of this project is to manage the versions of the data, okay? So what you're seeing here is the simplest of all DVC pipelines. There's basically 3 different folders here, one for annotations, one for images, and one for preview. I'll show you what the preview is just so you get a sense of what this project is. So these are images from The Mandalorian. Baby Yoda is segmented out. And the idea is if this data set is updated, then we just update these files here, and we don't touch anything anywhere else, okay? So now we have a project whose sole responsibility is making sure data is sort of the most up to date. So if we go back to the annotations example that I showed, the annotations are going to happen on this project because it's a data related activity. Then you go to the segmentor. So the segmentor is actually the project where we're training the model. And what happens here, if I go back to the pipeline, you can already see why the pipeline is useful because it's so easy to explain what's going on in this project. What I'm actually doing here is I'm importing the images and the annotations from the project I showed you a moment ago. So DVC has this notion for import, and we support it at DagsHub as a first-class citizen, which means that you're taking a non-code component. So it's like basically like Git submodules, but for data or models, okay? So the idea is you're taking the data from this other project and you're bringing it into this project. So if I go to images and I click on this, you can see that this actually led us to the first project that I showed you, right? So the connection is sort of built into how we are creating this model. And then the idea is this. So I'm taking the images, I'm splitting to train and test, and then I'm training a model, right? Now, what happens if that data, like the use case that I explained earlier, right? Like the data has now been updated, and there are 5 projects like this that are sort of consuming that data and building a model on top of that. Basically, if I go into this file, so this is the YAML file, like the metadata file that is saved into Git in order to support the DVC versions, you can see that this is the URL that I'm importing from, and that URL has a revision log. So it means that it's looking at a specific version of the data coming from that project. So what I'm actually able to do is I have one command, which is called like DVC update, which basically tells this other project, in this case, again, the dataset project, to bring in the most recent version of the dataset. And so the entire update process is you can check whether or not things have changed upstream, okay? Like if the dataset has changed, and then you can make a educated decision whether or not you want to update the project. Like maybe you want to update it because you want to be on the most recent version. Maybe you don't want to update it because the format has changed and you want to make sure that you update your model to support the new format before you pull in that update. And so that gives you sort of the interconnected ability. But this is not just, because DVC is so flexible, this is not just limited to dataset registries. You can also imagine that if I go back to this, you can also imagine that after I train this model, I take this model from here, and I actually push this into a model repository. So same as the data repository, but I'm pulling in a model from another project and I'm only managing model versions. And so then you have like one project, which is a model registry, one project, which is a data registry, and one project, which is actually sort of where the magic happens, where you pull from the data, you train the model, and then you push the model to where it's going to be deployed from. So Tom, for your question about like the relationship between data science and developer teams, you can, if you have that model repository, the developers only need access to that. So you can even manage permissions in a more sane way, especially if you can imagine that you have like sensitive data. Like maybe if this is like medical data, you don't want to give people unnecessary access to the data. And by this sort of a formulation, they only have access to the end result, which is really awesome. And this is something that I think is a recurring use case that a lot of companies actually use, including, among others, Tesla. And so I think this is really useful. And if you ask me, like, what is the direction that the future holds for how projects in data science and machine learning are going to be structured, I think we're going to see more and more of this kind of thing because it's so powerful and it enables teamwork in a much more effective way.
I'm guessing there's some way to set up Jenkins so that when you get something ready to go replace what's already on your production pipeline, it somehow alerts your devs that, hey, we're ready for you. We're ready for this new model to go into production. They probably even could say, oh, we're just going to let you control that. And so you set it up, it's seamless to them which model's been being used. Is that accurate?
Yep. So this is great. Like I opened a project as you were speaking, which is one of our users built this, and this is an automation of Jenkins. So this might look a bit scary, but I swear it isn't. If you haven't looked at Jenkins files before, this is basically a Jenkins pipeline, okay? And you don't need to understand everything that's going on here. We also have a blog post that this user wrote and we published on DagsHub. So if you look for Jenkins in our blog, you'll find it, and he dives into all the details. But what actually happens here is he created a pipeline, and you can see that there are DVC commands here. So basically what he's doing is every time there's a new pull request, he pulls that information into a Jenkins runner, and then he checks whether or not something has changed in the DVC pipeline. And if something has changed, he retrains that model and then pushes the trained model back to DagsHub into that pull request. And so you're actually creating a pull request experience that includes the review process for the model. And so what hasn't yet been built, and I welcome anyone from the audience that wants to make a contribution, and I would be really excited to see this, but it's relatively straightforward to build, is that once you merge that pull request, you should take that model and push it into the model registry. And then you can also, like DagsHub supports Slack and Discord webhooks, so you can also notify the dev team that there's a new model ready for deployment. Or if you want to take it to the next level, you can there are a lot of examples where people sort of on merge into master want to just go ahead and deploy. And so like one of the examples in the first project, if I go back to Safdadep, I think I closed it. This is actually a pull request that I need to accept. Another user opened this for us, but he created like a Gradio app so that you can deploy it to Hugging Face spaces every time you merge in a new version, right? And so you can imagine that could work for any type of deployment. That gives you sort of this end-to-end experience, which is like, I guess the title for this would be like Git flow for machine learning, like real Git flow for machine learning, which I think is a really powerful notion. So yeah, so you can check out his contribution. It's not yet merged into the original Safdadep, but I'm going to do that pretty soon. And yeah, and I think that's really exciting. So by the way, this is it. I don't think I have anything else to show. And so we can use the last 9 minutes for audience questions.
Yeah, we don't have a hard stop, but yeah, let's open up for questions. Hugo, you came on camera. What you got?
Okay, so first thing is I really do not like writing Git code, so I get to use Git clients a lot. You could see I use GitHub Desktop and any other clients that I get to use. So I'm wondering if you have something like that for DagsHub, and if yes, what would it be? Yeah,
so personally, I'm a source tree fan. I think that it's really nice. By the way, this is a general recommendation. If you know basic Git and you want to improve your Git skills, think like a Git. Okay, this website is, I would argue, the best web tutorial for developer related things ever written. I know this is a strong statement. I think it's amazing, right? So if you want a better understanding of Git, I really, really recommend this. But I also use SourceTree mainly for like the visualization, the seeing the project history and everything. There's currently not an equivalent for DVC. You can use SourceTree or all of the Git clients with DagsHub. Like it's fully, like DagsHub is a Git server for all intents and purposes, and so everything should work with DagsHub as well. For the data versioning part, it's currently limited to like you need to use the command line. One of the things that we did you can also install like Git hooks and things like that. We created a project, which is, I guess the easiest way to get to it, sorry, it's fastds.io. So we created a fast data science for partly for that reason. So this is an open source project. You can see it on GitHub as well. And the idea is, it combines Git and DVC and makes it more convenient to use. So one of the things that it does is it prevents the whole, I guess it's nicer to see it here. Instead of like doing Git in it and then DVC in it, you do FDS in it, and then it does both, right? And we do the same thing for a bunch of sort of different commands, like adding files and pushing files and things like that. We even created an FDS save command, which just, or I guess, yeah, I don't have that example. But we created an FDS command, which basically does everything. Like it saves everything and then it pushes it to the remote. So you can actually do this with like one command, which is really fun. So those are the two recommendations I have if you want to start, if you want to simplify your life. I think that there is like a DVC VS Code plugin in the works, but it's not like but that's not out yet, and I'm not sure how that would work when it is out. So I can't promise anything. But yeah, but I think that the work with DVC is mostly like very targeted commands, and then you use Git most of the time to push. So I didn't explain how DVC works because this wasn't sort of the focus of the call, but the idea is like every time you change something in a DVC file, basically what happens behind the scenes is DVC makes sure that that file does not go into Git, because Git is very bad at managing large files, but instead it creates or edits a text file, which is then saved to Git and pushed to your Git remote, right? And we use those text files at DagsHub to piece together, like do all the magic that I showed. And so the idea is you would have to run a small amount of DVC commands and then just run the regular commands that you do with Git. And so I think it would be relatively straightforward to get used to like adding the 1 or 2 commands that you need for DVC, and then you can use your Git client, Git UI for whatever you're used to using that for, if that makes sense.
I love this, Dean. I got to a point where with Git, I wanted to go to the next level. And I remember at that point, I started looking for, doing Google searches for Git philosophy, understanding Git deeper. And I came up with some really great explanations, but let me explain something to everyone. We're talking about one of Linus Torvalds' greatest creations, Git version control. So it's so feature rich, it's so safe, it's so powerful. You can even if you feel like you're going to break main, you have it. There's a way to dial back. So it's just one of the genius, by the way, in case you're not aware, Linus Torvalds, the inventor of Linux, super great guy. Not very personable, but not because he's not nice. Just he says he doesn't do so great with people. He's got a TED talk where he said, yeah, I'll give a TED talk, but I want to be interviewed. I don't want to prepare a talk. And he did great on that. And but thank you for sharing that link and for doing everything you can with DagsHub to make Git operations easier. But I got to tell everyone, I find that like 95%, at least on personal work, I'm doing the same 3 Git lines all the time. So don't let it scare you away, guys. Okay, Hardik, you have a question.
Hi, Dean. Really liked your presentation on this. So to be giving like a brief description, like I'm pretty novice here in data science. So I haven't hardly had spent like 2 or 3 months on GitHub. So some of the things did go over the top of my head, but I think I was able to just relate it in terms of, how to use GitHub and the differences in the GitHub and DagsHub. But I have a few questions, those are, so firstly, I want to ask like, how did you guys decide on this name as DagsHub and the logo? And the nextly, what I want to ask is, in GitHub, you have some sort of a profile so that it's in terms of perspective of an employer, they can see how and what progress you're doing. Is that capability in DagsHub?
Yeah, sure. Okay, so basically 3, I guess 1 point and 2 questions. So beginners, and then you had, I missed the middle one.
So the first question was about the name, the DagsHub.
The name, right.
Yeah,
and the
logo.
profiles. Yeah, fair enough. So relating to being a beginner, this is the homepage for our docs. There are 4 options for you that I think are really useful in making sense of what's going on. If you're a movie person, like a YouTube person, we have the interactive session. You can see this is like a 30-something minute video that explains like MLflow and DBC and working with DagsHub. So if that's your cup of tea, you can do that. You have the Hello World project, which is like the classic get started project. So this will guide you through everything. If you want to do the same thing, but you prefer to do this in Colab, in Google Colab, you have the Hello World Colab. It's the same project, but you can do that on sort of, instead of setting everything up, this is just set up and you can just run this end to end basically. So those are 2 options. And then pre-configured Colab is just like, we built sort of this, and this also relates, Hugo, to what you said. We wrote like a Colab that has a lot of the boilerplate code, so you don't have to understand exactly which commands to run for each task. So you can try those 4 things, and I think that's that could be really helpful. I'll answer the profiles second, and then we'll get to the logo. So yes, every user has a profile. I want to actually, like, this is my pet peeve is I'm very design conscious. So I want to make this look even better. But one of the most heartwarming things that happened last week is one of like someone who's a director of machine learning at a very large company tweeted, I want all the people applying to our company to send us their DagsHub profiles, right? So we definitely have that in mind, and we want to build a place where, like, I think that this could be much better, right? Like there could be here, you could show things that data scientists care about more prominently, and so this is sort of the profile right now. You can see sort of, I guess I could add a bit more information here, but you can see different things about sort of the user. You can see sort of the different projects that you're working on, and sort of that already does exist. With respect to the name, so a DAG is a directed acyclic graph. So that means that it's a graph that has like basically this pipeline that I showed you. Let's look at this. So crap, this is not a good DAG. Let's go to Saftadep. So basically, this is a DAG, right? And the idea is like there are no cycles in this graph. And there's sort of dependencies and outputs. So each node is connected by an edge with a direction, right? So that's a directed acyclic graph. And the visualization for this graph was the first feature that we built for DagsHub. And so that's part of the logic behind why we called it DagsHub. And then the reason for the logo is, if you've seen the movie Snatch by Guy Ritchie, the Brad Pitt is playing a character that is like has a very heavy accent, and one of the scenes he asks like, "Do you like dogs, mate? Do you like dogs?" So, and he means dogs, of course, and so that's why we chose a dog. And then the full logo is a half dog, half fish, and the reason is that in Hebrew, dog means fish. So we combined a bit of local terminology to make it especially fun. And then one of the things that someone pointed out, like, admittedly, we've discovered more meanings after we invented this. So up to now, this is everything that we meant to when we started. But afterwards, someone told us, it's funny because GitHub has a half cat, half octopus. So it's kind of like on the same notion, which I sort of honestly we did not think about that. And then the other thing is, my name is Dean and my co-founder's name is Guy. I honestly, we did not plan this, but DAG is also Dean and Guy. So it so happened that we covered a ton of different bases there. But yeah, I like the name. I think it sort of resonates both with the fact that it's close to GitHub or sort of inspired by GitHub, but for data scientists, which arguably care more about DAGs. Yeah.
May I guess why you chose the breed of dog you chose?
You can try, but most people guess wrong. So go ahead.
Oh, darn. Because I've seen your dog and it looks a bit like your dog.
So I am I've been a sort of hobbyist designer since I was very young, and so I actually am the one who drew the logo. But I'm not that good of a designer. And so when we got started, that was basically when we adopted Sunny. I'm pointing at her; she's over there on the couch. That's when we adopted her, and I tried to draw her, but I was not good enough at sort of making a caricature of her. And so I decided to draw her best friend, which was a Boston Terrier, and so that's how we got the logo.
Okay.
But yeah.
Because everyone here is probably wondering, why didn't you use Caleb, who's my old English mastiff? He's huge. Anyway, I had to put that in. This is great, Dean. I mean, I was already committed to trying to learn DagsHub and integrate it more and more into my work. But now I feel like, oh yeah, I'm more excited to do that now. So one last question to help everyone that came here. How can people, I think you've already answered this. You may just be referring back to a previous answer. What's the fastest way to get up to speed and make the best use of DagsHub?
Yeah. So maybe I didn't mention this, but like everything I showed you is completely free for open projects. You can just sign up and start using it. We also, the platform is also free for private projects, up to 3 collaborators, but especially if you're working on like building out your portfolio, you get everything for free. And you can start, sort of start today. You don't need to wait for anything or get permission from anyone. If you're working on like social good or collaborative community projects or research or something like that, and you need something that you don't have, reach out to me and I'd be very happy to help, even like outside of the features that I showed, like giving you early access to things that we're building and are not yet officially released, and things like that. I'd be happy to do that. And then, yeah, you could just sign up. You can sign up with your GitHub account, with your Google account, and create a project. The docs page is sort of the place to get started if you're not sure how to get started, in the sense of like the tutorials that I showed. Yeah, that's basically it.
One last thing.
Yeah.
Let's see. I think I'd be better if I did it this way. Hang on. So I finally got around to doing this, Dean. So here's my personal web. I'm trying to build out a portfolio page, but this is hosted for free on GitHub. And I've got little icons to integrate it and LinkedIn. By the way, if anyone wants it, this is our like our font awesome version of integrated machine learning and AI. So if y'all want this icon, let me know. I'll teach you how to get it incorporated like I did. But can we do something like this on DagsHub? So, like a personal website that will launch?
Yeah. So currently the answer is not yet. That's something that we're thinking about. Like, what would be the data science equivalent of this? Maybe building a Streamlit app or something like that. But currently you can use GitHub. We have a few examples of people using Heroku and things like that. It's something that we were thinking about. And yeah, I by the way, apropos like the discussion about logos, I really like the volume integral. I didn't mention this, but I studied physics and computer science. So volume integrals are both one of the things that keeps me awake at night, and also one of the most sort of exciting notions that exist. So it's a good logo.
Thank you very much. All right, well, we better sign off. This exceeded my hopes and expectations. I'm even more excited to come up to speed with DagsHub than previously. And I'm going to go ahead and stop the recording.